Labas, eso Tadas. Hello, everyone. My name is Tadas. I work at Mozilla. It's a pleasure to be here back at PyCon once again. So today we're going to talk about Python tooling at Mozilla. So I'd like you to also meet Kit. He is our new mascot at Firefox, and he's also going to guide us through our journey because it's good to have a fox along when you can. So if anyone's interested in talking about tea, classical music, cold swimming, cats, anything, come find me a little bit later on. Those are some of my other interests. But I'd like to discuss a couple specific topics with you that I've broken down into 9 sections. And of course, each subsection could be its own talk and discussion as well. So this will be a general high-level overview. Partially around some of the tools and strategies that we use, but also hopefully to share some of the lessons that we've learned through some very painful experiences and also some things that have ended up working very well. I currently write more Rust code now than I do Python. We use Python primarily for a lot of our testing and our Rust applications, which I'll get into a little bit later. But some of my Python experience on previous teams within Firefox's suggest engine is all written in Python. The service is called Merino Py. So if you're curious at looking at it, it is of course open source, and that's how Mozilla in a private way is able to share a lot of the suggestion data with users. My 2024 talk was specifically about Merino, but it's evolved quite a bit. So everyone said it would be straightforward, requirements would be clear, and they seldom ever on. I'm not sure if anyone has ever played this game, the Oregon Trail. I've used this in previous talks before, but either the game ends in the entire family or group getting dysentery, or your cabin is crashing into the water here. So very often the experience of development can be this. Either you have a major roadblock or problem that impedes you from being able to achieve a specific objective, or later on, as time progresses, you struggle with some of the tooling that you have that holds you back. So this may seem very obvious, but I'd like to start with the idea that we should often evaluate what we actually need before we make commitments. And what's important to consider is that if your application is either a new one that you are building from scratch, or if you're doing a major refactor, this will obviously affect the decision matrix that you have when evaluating what you should do. Obviously, there are switching costs to consider if you're evaluating a new library or framework, but if you're starting from scratch, very often you have a lot additional flexibility. So that's why we're spending a little bit extra time considering what some of your development needs might be day to day. And then exploring some of the architectural topologies and how those will influence your deployment strategy, your testing, the various contracts that you have to enforce, if there are other interrelationships with other services. So you obviously cannot predict the future. It's difficult to know how applications evolve over time. But of course, I like to invoke the Zen of Python as often as possible, in that start with the sort of batteries included approach. Always see at the lowest level how you can achieve what you can do with the fewest libraries possible. Now, of course, these days with a rich tool set, that's not always the most sensible thing. You don't want to be writing something entirely from scratch. But you do want to consider what you can do with a greater level of simplicity before necessarily jumping to something. Again, I mentioned new projects or refactors will significantly affect the approach that you end up taking with your project. Most importantly as well, institutional knowledge is incredibly important, and at organizations, it is actually surprisingly difficult to sometimes get information from other teams. Everyone is so deeply focused on their particular deliverables or projects that very often you're missing essential context from another team that might have actually solved the particular problem you're trying to solve very well. So make sure to attempt to communicate across teams and with your colleagues and communicate openly about that. So the types of tools that you want to maintain your code better is a mixture of obviously type hinting, which I'm a big evangelist of, linting, automatic testing, and release processes that are very important. One thing that we do at Mozilla quite well is that whenever we're considering an alteration to our architectural structure or the inclusion of a particular tool, we like to do what's called an ADR, which is an architecture decision record. And a lot of our repositories will have these ADRs in public, which allow developers within our team to give feedback on the pros and cons of using a particular tool. So Mozilla has, an open source shareable ADR template. So I highly recommend this is something that you can pick up yourselves. We'll get more to workflows afterward, but it's essential that they are repeatable and consistent. And one final thing that I'd like to note is that whenever you're setting on into working on a new project or doing a refactor, you want to imagine once the project is done, what it would be like to onboard a new engineer onto that product or project in particular. Very often we get so mired in the daily tasks of what we're doing that we don't consider maintainability and flexibility. And for open source, this is really important because if somebody is going to be using your tool, if you basically leave them out to dry with documentation, with setup, with configuration, it'll be very difficult to convince people to use your projects, or they'll end up being very frustrated. So we're going to briefly talk about abstractions and interfaces, and this is a subject I'm very interested in. I don't obviously want to have a whole lot of time to get that deeply into it, but the temptation is that when you're using a tool or framework, is to immediately actively go ahead and use it as is. Now, in a lot of cases, this does make perfect sense because the whole reason why you're incorporating that tool is because it does provide those abstractions in the first place. But there are cases which you want to be very careful in how you approach implementing those tools. Not sure if anyone watches Star Trek, but there's a famous quote from Mr. Scott, who says, "The more that they overthink the plumbing, the easier it is to stop up the drain." So this is a slight caveat that over-engineering is just as bad as under-engineering, and you want to be very cognizant of how you go and take your approaches when either creating interfaces or not creating them. So it's just that, depending on your particular use case, it may shift one way or the other. So a car is viewed as a single object with a unique behavior, which is to drive. We don't consider a car in sort of individual parts. Abstraction roughly allows people to basically use a car without knowing its complexity. This is rather the key that we have to consider when working with a particular library. Users can ignore the details of the engine, the transmission, and the braking system, and allows them to utilize the object as a whole for driving. So in the context of programming, you want to consider, could you potentially add a different database layer? Would you perhaps want to support Spanner, Postgres, and MySQL all at once? If not, you can go ahead and simply implement it. But in the case that you may have different databases that are available to different customers, you may run into the situation where you want to have an abstraction layer of a root database class, or as I'll talk with Rust a little bit, with a trait. So you essentially want that layer of abstraction to make your life easier, that any sort of database behavior is normalized within your logic. So again, it's to layer the semantics of complex systems and breaking them into imaginable pieces. So again, not that everything needs to necessarily be based on class-based programming or design patterns. There are a lot of useful lessons that we can consider when implementing these types of tools. Coupling is something that's very important to consider when implementing a lot of your tools, is that if two parts are too tightly linked, they are extremely fragile, right? You want to be quite cognizant of, again, how you're pulling in these libraries and implementing them. Low cohesion is obviously an excess of responsibilities. I can see this sometimes a lot with certain Python projects where you have, code that has excessive responsibilities put in within a single function, or there's a lot of state that's often maintained. Some of these things may work, but they can be incredibly fragile. So one thing I want to comment on, how many people here have worked with Rust a little bit or actually dabbled with it? Yeah, great. One thing that Rust is excellent for is its use of trait implementations. Now, these are somewhat similar to abstract base classes in Python, but what they do is they allow you to implement essentially a concrete type and create a contractual agreement. Right? So typing.protocol is an alternative within Python that allows you to do this, but you can essentially define a structure or an enum, and then based on that, apply particular traits to that struct. So you'll see in Rust, the impl drawable for circle allows you to create that contract that said circle must always implement the draw function, more or less. And then with abstract methods, this can be the case. Taking this approach when implementing a lot of logic from other libraries or tools can be very useful. And again, creating that extra layer of abstraction. So some of your daily development tools. I'm going to summarize some of the useful tools that I've used on a number of Mozilla projects that we found to be extremely helpful. Of course, it's not completely comprehensive. I'm very curious to talk to a lot of you after and see sort of what you've used. The talk earlier today on Apache Airflow was really insightful and interesting regarding some of the tooling that they use. most of all, I'm going to advocate for using typed Python. This is definitely my Rust developer speaking at this point, but if you're not using typed Python at this point, please consider it. Okay, so obviously we use a mix of poetry and UV, depending on different projects. But the chief benefit is obviously using the pyproject.toml and the poetry.lock file in particular for poetry. The lock files ensure that there is consistency across different platforms with your dependency builds. We use MyPy for static typing, but I'll get into another interesting Astral product that's coming out now that might be a competitor to that. Rough is very well understood to be probably the best linter and formatter out there these days. I'm sorry to say that to Flake8. That's a great product also. But we use Bandit for static code analysis to ensure that we're making sure that there aren't any CVEs sneaking into our code. And then Make, which is a bit of an odd choice, but a lot of our projects at Mozilla use Make. Is anyone familiar with Make? It's more so used for C and C++ programming for compilation, but there's some pretty novel ways you can use it. For testing, we predominantly use PyTest, even within our Rust applications. And then we use Locust for load testing. Finally, for environment management, PyEnv and virtualenv is kind of our go-to. Obviously, UV comes built in with a lot of the environment management. So for those projects, that's what we use. And of course, the classic VENV, in some cases, it is the best option. So yes, my pet peeve, for Fox's sake, use type hints, please. And again, this is my Rust developer speaking, but you basically self-document your code when you have type-supported Python. It gives you just a little bit of like additional flexibility and an ability to understand the code better. I've certainly gone back and forth when, say, we've added type hints to a lot of our code, and it's straight. I've noticed distinctly how much longer it takes me to understand Python code that is untyped. Especially when you're dealing with a programming language like Rust, where you know specifically what your inputs and outputs are. And the beauty of it is, you don't have the enforcement of the Rust compiler. Anyone who's worked with Rust, I know, obviously says the compiler is their favorite part of using Rust because it's always barking at you for every little mistake you make. With using MyPy, alternatively, it's not going to prevent your code from running, but it will give you that level of assurance. You can integrate MyPy into your IDE. And again, your code can remain dynamic. So you can retain the duck typing benefits of Python without having to necessarily sacrifice anything. Now, TY or Ty, I don't quite know how to say it, is again a new entrant from Astral, the makers of Rough and UV. They are currently launching this in beta for use. They say they're using it in production. I wouldn't necessarily quite suggest that till it's maybe had a little more time to settle, but it's exceedingly fast. And they say, built on incrementally enabling them to selectively rerun only the necessary computations when a user edits a file. So using caching obviously makes it more efficient. And like all of their products, it's written in Rust. Now, makefiles. I won't spend a whole lot of time on these, obviously. I highly recommend you go and look them up yourself if you're curious. But it's essentially a shell language that's used for code, more often in C and C++. The beauty is it comes pre-built in most Linux systems, so it's usually already there. And it's a great way to basically run shell commands. But the nice thing is it's completely agnostic. So you can put Python code into it, you can run Docker commands, you can run shell, you can do all of these different efficient things, and it will essentially interpret that logic. I'll mention the phony target in particular is used to declare that a target does not represent a file. So that makes sure that the associated commands are associated with that particular target. So I wish I had a little more time to get into it, but there's a little example at the bottom. But if you want a very sort of quick, efficient tool to manage sort of more verbose commands, Make is an excellent choice. Now, we'll get into dependency management, which is often everyone's favorite subject and can often be extremely contentious. Pip is obviously still very much live and well. The use of a requirements.txt is still quite standard. But the problem is the single largest detractor to that method is that you do not lock any dependencies. So you can have inconsistency between different platforms. You may do some local development, push something up to GitHub, it runs in your CI, and you'll have divergent versions sometimes. And that can depend on, obviously a patch landed for an external library. So these days I highly recommend everyone either switch to Poetry or UV. Obviously, it's going to depend on your individual use cases. UV is, of course, much more efficient and fast and has a whole slew of additional benefits that we've somewhat enumerated. But the key is that you have predictable and repeatable installs, which is the cornerstone of using these dependency management tools. If you use GitHub, which I assume most people do, having a dependabot configuration to keep track of your dependencies is a really efficient way to manage all of this. And you can also group your dependency management into a single call so that at a certain cron period, it will check all of your dependencies and you can update them all at once. The other tip I'll suggest is that every now and then go into your lock files, or not your lock files, but your pyproject.toml files and update your semantic versioning tags. It's very easy to sort of get far behind and not necessarily consider that, but if you are pinned to a very specific version, like say dependency 2 of something in particular, and you may have accidentally annotated it with some sort of semantic versioning, it may be the case that that library is not getting updated over time, so you might want to essentially evaluate it. So I'd add that to sort of your quarterly cadence of looking at all of this. Additionally, here we've got dependency groups, which are essentially the sort of root and core of why Poetry and UV can be exceptionally beneficial in that you can separate your dependency groups based on their purpose. So there can be different parts of your module or repository that need different dependencies. Say you have a monorepo and you have a number of scripts that run and operate. And additionally, if you have development dependencies, there's no reason that you need to be pushing these development dependencies up into your production environment or building. So this way you can segment the two. And again, Poetry versus UV, I recommend you do a little bit of research and consideration on your own side. The major benefit of UV is obviously its speed. Its tool set and flexibility is increasing considerably. So it's basically up to you, but honestly, if you are using pip at this point, it is worth evaluating switching from one. There are greater switching costs if you're already using Poetry. Switching to UV, you'd have to have some pretty compelling usages or use cases to do that. So it may not necessarily be worth the change. But again, that very much depends on what you're doing. All right, now we'll move on to environment management. So the objective of environment management is to create a isolated and repeatable environment to install your application and dependencies onto. So as I've mentioned before, UV has some of this built in. VENV used to be the Python standard that was essentially used across the board. And in many cases, it still can do the job quite well. I will share slides later so everyone can take a look at some of the comparisons. But as you can see, the sort of barrier for entry is quite low for all of these. I find that we've often used PyEnv virtualenv more often recently because you can create configurations that as you move through a repository, say you have different Python versions or different requirements, automatically that workspace can be triggered, which again, UV can do now as well. But that's essentially a very effective tool. Say you have something that's dependent on some particular code that needs to run in Python 3.12, for instance. If you shift into that particular directory, it can automatically invoke that environment and you can make use of it. Building images. So at Mozilla, we build Docker images and push them to the Google Artifact Registry. That's specifically our internal production environment registry where we have a safe place to put our images. And then most all of our other services are then pushed to GHCR, which is the GitHub Container Registry. So you'll have a little widget in your GitHub repo that shows the different tags and different history of the deployments. And you can essentially just pull down any of our repositories. We used to use Docker Hub, which is totally fine. No complaints about that either. So either are fine. There are a number of optimizations I could talk about that we've worked on over the years with Docker. Recently, Docker has launched hardened images, which are a great security improvement. So I'd recommend you look into those. But Docker layer caching is essential. It's very easy if you somewhat take some missteps in your Docker files that you could be doing a number of operations excessively and slowing down your Docker builds. And then additionally, multi-stage builds are something else to look at. I won't have any time to talk about that today, but I advise you to look into those subjects. We use GitHub Actions now. We used to use Circle CI, which was also a viable alternative here. But for example, you're able to simply define a collection of different tasks that can run. Later, I'll show you the slide of what our actual one of our services deployments looks like. There are a couple of best practices that I really like to advocate for. I feel it's better to have a single workflow. It's much clearer. Obviously, you can distribute workflows and have them run sort of concurrently, essentially. But the beauty is of a single workflow is that you can better visualize the entire process of your linting, of your testing, and all of this. Um, so you want to be somewhat cautious. Of course, there are exceptions to this rule, but I highly recommend use a single workflow. Never explicitly just trust third-party actions. You don't necessarily know who wrote them. They can be extremely vulnerable. And in that case, there's a tool called Zizmore. That's great for static analysis of all of this. There's a couple of specific points I put here a little bit later, but one of the most important things to do is to often pin the specific SHA of the version that you're using, and not just version 3.3, but the actual commit SHA of that. There have been some cases of some packages being sort of maliciously injected. So you can generally trust the GitHub maintained ones, but if they're third-party actions, you should be quite careful when evaluating them. I'll just move on from that. There's a number of things, but again, I'll share the slides so you can review these on your own. So this is one of our core main workflow runs for the sync service, which again is a Rust project. But here you can see we have a number of environment setups that then push through to a number of checks that then run our integration, unit, and end-to-end tests along with builds. So the beauty of this particular job is that we can run our testing concurrently along with a number of our additional checks. So we essentially just create our environments, cache the environments, then begin to build the images and test against them. And the nice thing is then we don't go to the trouble of actually building the final image that we push until all of the tests have completed. And briefly on testing, our test strategy is 4-tiered, where we focus on unit tests, integration, end-to-end, and load. So obviously maintaining test coverage is an important consideration you should have. It's not necessarily forced to be dogmatic that you have to keep to a particular amount. Again, it will really depend on your use case. Fixturization is incredibly important. I do see a lot of Python repos still these days using sort of the old unit test library as opposed to modern PyTest, and they're very often class-based tests. So we've been doing some work ourselves to modernize some of those, but there are a lot of beneficial optimizations you're leaving on the table if you're not implementing PyTest. Again, there's a couple of best practices with, assertion, the way that you write some of your assertions, the way you deal with fixture chaining and actually pulling fixtures into one another. But I'm running out of time here, so I'm going to move on a little bit more quickly. Yeah, too bad I don't get to talk about these, but you'll look a little bit later. At least you catch the foxes, right? That's what matters. Finally, a little bit of our deployment strategy is that we use the GCP Kubernetes engine so that when a commit is pushed to main, the GitHub Actions workflow is triggered. Then we merge the Docker image and push to GAR, and then we use Argo CD for our building. So that again is our Actions workflow. And then essentially once the PR is merged into main, the CI builds and pushes an image. There's a GitHub repo update, and then Argo CD is able to pick up the differentiation between the two. Then after that, you can decide to deploy to the cluster, and our strategy is usually always to push to the stage environment first. And we also have the ability to invoke ephemeral environments, which are sort of preview environments, essentially. I won't have much time to talk about telemetry and observability, but the continuous collection of logs, metrics, and traces and their purposes is incredibly important to consider. The only thing I'll show you very quickly, we use Grafana and Prometheus sort of as our open source tooling to collect and manage a number of our metrics and then visualize them, and then Sentry for error reporting. One note on Sentry, be very careful, make sure to add filtering. You don't necessarily need to collect more than you need. I have a code example there that you'll be able to review a little bit later. And then the last thing about observability and telemetry is that there are 4 golden metrics defined by Google's SRE team. There's a very famous paper dedicated to monitoring distributed systems. And the 4 are latency, traffic and throughput, errors, and saturation. So those are the 4 that you want to look at. So these are quite self-explanatory. You've certainly seen them before. And yes, Arctic foxes are very good at observability, as you can see. So I'll leave you with a couple just final points to close out. Evaluate your needs regularly. Make sure to document, clearly use the ADR, and consider the way that your system is changing. Maintain an abstraction layer if possible between your libraries. Please use type hints. Maintain repeatable and dependable workflows. Use concurrency and caching in those workflows. separate test concerns by using fixtures, and then imagine the project from the perspective of a new engineer. And then, of course, the 4 golden signals. So thank you very much for the time. Sorry, I wish we could have gotten into this a little bit more, but I really appreciate it, and feel free to come up to me and ask some questions. Ačiū.